no reason. I just don't know what AI means. Not anymore.
AI.
So you say, oh, you know what? I will just use LLM as a rerun. Bing was optimizing for this metric called NDCG.
Welcome to One Little Coder podcast. Today we have Nirant. Nirant is a very popular figure in the NLP space in India. He runs a very popular GenAI WhatsApp community. And he's also the author of NLP with Python book. Nowadays, we don't call anything NLP, everything is AI. But when it was NLP, people would have probably read Nirant's book. And Nirant is also a person of hot takes. So probably we'll have a lot of hot takes today. Nirant, welcome to the podcast.
Hello. Thanks for having me. Yes,
Yeah.
let's try to have it a low temperature setting.
Setting. Cool. For people who do not know you, can you introduce yourself? Like, what do you do? What's your current projects and all those things?
Yeah. Today, I'm primarily a machine learning consultant and I specialize in search in particular, and within that, mostly language search and a lot more focus on products or experiences which require, let's say, RAG or search behaviors. This could be code RAG systems where you are, let's say, using RAG to evaluate, using a compiler and test cases to see if it's a working solution. Then classic search problems, let's say you're doing something like a Slack, Google Doc search, that kind of problems. Building search for internal enterprise document discovery, which is beyond messages, like the Slack and things like that are mostly messages. And then there is documents like PowerPoints and things like that. A lot of what I've done is in some ways related to healthcare, which let's say one of my clients used to be in dentistry chain, dentist focused medical transcription for dentists in Canada and East Coast hospitals. Then similarly, one in oncology, again, mostly looking at prescriptions and trying to map it to the diagnosis and seeing if this is exhaustive history, not transcription. We already had transcriptions and it was about tagging and classification that, okay, this is a prescription versus this is a diagnosis versus this is a test which has been prescribed. So different kind of labeling tasks, pseudo labeling tasks. This used to be harder before. I did a lot of these problems when the state of the art used to be the universal sentence encoder and not. This is before sentence transformers, to put it in context. After BERT, before sentence transformers, a lot of these problems. So yeah, that's the kind of background I come from. Along the way, I've written a book. I've mostly been active in open source in some shape or form. For instance, I've maintained awesome NLP repository, I think, which has about more than 10,000 stars going back to. I've maintained that since 2018 on and off, and it's also recommended by Stanford, some Stanford courses to their folks. I think you already mentioned the book, and more recently, I built an embedding library for high throughput performance use cases for Quadrant called Fast Embed. So that's the context.
That's nice. I liked how you humbly started saying I'm a machine learning consultant, and then you went on explaining about search, RAG, and fast embedding. Like, is there a reason, or it just like came naturally?
Which part?
Is there a reason why you said machine learning consultant, not like an AI consultant? Like, is there a specific reason?
Yeah, I mean, there's no reason. I just don't know what AI means. Not anymore.
Not anymore.
So, so there's the definition of AI, which probably like a Forbes will tell you and Twitter will tell you, and then there's the definition of AI which we have grown up in, which is mostly like we have largely thought of AI in what we now call memory and planning problems ways. Like for instance, we used to think about SLAM in the robotics context, or we used to think about reward modeling in case of reinforcement learning. I don't think we do any of those things in today's language modeling also. So I'm a little and then, although yes, there is some degree of self-supervised, semi-supervised, but the moment you have architectures or methods which have some sort of preference optimization, be it DPO or basically RLAIF largely, it's very difficult for me to say that, oh, this is AI because the feedback, like, yeah, sure, there's some version of self-feedback because the feedback comes from AI, like a different LLM or a bigger LLM or something like that. But to me, it has I just don't feel comfortable calling it AI in the way, let's say, Dartmouth folks would have said in the first AI conference in 1950s. I don't think it's not exhaustive enough. I would say it's not general enough. I think that's the better way to look at it.
I wouldn't have asked this question, but because you spoke about planning memory and the way we call AI, what do you think about agents? Like, do you think agent is an agent?
So there's this two. I think I'll add a little more flavor to that question so that I think it's fun and useful to talk about it. So there are agents as we see it today, and I think they're largely built on LLMs, which are terrible at planning for the most part. So anything which requires look ahead and then correction, we do some hacky version of that. So, for instance, there is a paper in RAG called Reflection. There is some other methods called Corrective RAG, which are basically implementations of look ahead, then correct, look ahead, then correct. In the more recent blog from Lillian Wang, she describes a method which basically does something like you generate, then try to attribute it back, and then basically make a citation out of that in a QS structure or a RAG structure, which is also a version of okay, you're going ahead in a pipeline and then coming back. It's a you're solving for the same planning problem that you cannot do frequent lookbacks by doing different methods of doing lookbacks. Sometimes you're doing it after generation, sometimes you're doing just before generation, sometimes you are doing before retrieval also. Like you do retrieve partial and then rescore and then do citation check and then pass to LLM, so things like that. I think that this is the point in time description of how we are looking at planning today. My belief, without any, and it's a belief or an opinion, is that LLMs will get better at planning dramatically from today in the next 2 to 3 years. If nothing else, the scaling laws indicate in that direction. Because the kind of like today, I would say if I were to use a very bad rule of thumb, I think most good LLMs like GPT-4 or Claude Opus level LLMs, they can do somewhere between 2 and 5 steps of reasoning, and that's usually a zero shot or one shot. Okay, I'll give you one example of reasoning and then you just reproduce it. Chain of thought is basically giving a scratchpad to reason. The ANT tags which Claude uses in their Sonnet 3.5 for element generation is also variations of these approach, right? We basically have given a scratchpad and said, okay, within this, I have taught you via some method, fine tuning or instruction tuning or preference optimization, that this is what you have to do here. This tag means this kind of thing. I think LLMs will get better. And then this kind of performance is now visible at like 70B models, which I used to think was a function of very, very large mixture of experts. But now we know you could basically do it with like 7 cross 8B or 8 cross 7B or something like that, right? So that means that there is and we know that given the quantized performance of a lot of LLMs, that these models are still over parameterized for the performance we have been able to extract them. If this was not the case, when we did quantize them to something like 4 bits or 2 bit, we would lose a lot more in terms of reasoning. But what we actually lose when we quantize is mostly world building, right? Like models forget facts. They don't, and we call them hallucination, but the reasoning is still intact for the most part. However bad it might be, and there's some degradation, of course, in reasoning also, but it's facts which we're losing with quantization and not enough of like yes, and we lose a lot of facts because LLMs are great at memorization. So yes, coming back to your question, tying all of this context back to your question, I think LLMs will get better at reasoning, and I think if we can scaffold it cleverly enough, either by reducing the need for planning a zero shot or one shot, and let's say we allow it to do a few shot or multiple tries, or to get better at look aheads, basically model planning as graph problems or discovery problems, or graph walks, perhaps we can get dramatically better at it. Of course, all of these require some element of memory. Now, whether the memory has to be probabilistic, like let's say friends at Mem0, Taranjeet and folks from the community, and now at YC, and there's a few more folks who are looking at different variations of memory, different designs of memory. Dot from New Computer has an element of memory. I think there are South Park Commons company. So there's this bunch of attempts at doing this. I'm not sure if any of these map directly as a separate component, or does it have to be integrated with the scaffolding which implements planning itself? But most approaches which I see which are engineering accessible right now, like an open source implementations, so to say, that is what I'm calling engineering accessible right now, don't have it tied. I think people go either very deep in memory or they go very deep in saying that it's just stateless. Yeah, that's the two directions I've seen, and I don't think both of those are fully mature yet. And I think as the LLMs get better, both of these will mature much faster.
Yeah, I think the fact that Mem0 is trending on GitHub is a testament that everybody is interested in this subject. But like you said, I think most of these implementations are like trying to figure out like way to fix this jigsaw and the jigsaw puzzle and figure out, okay,
Yeah,
where do I give
it's a
memory?
design problem pretending to be a product problem. So
Nice.
yeah,
You have been building search, you've been in the search space even before LLMs came in. Like, what do you think has changed with LLMs and before LLMs?
that's a great question. I probably have a great diagram for this somewhere. Not sure if I have it at hand. But one of the things which has really changed is the cost of doing search. And when I say cost of doing search is dramatically different, it's not just in terms of generation, which makes search more accessible, but also in terms of how much feedback you need, what kind of feedback do you need. All of those questions are very different today. Give me a second. I'm looking at a diagram which, if I can fire that up. Yep, found it. Let me, is there a way to share screen here? Yes, there is. So this is a diagram from Cosmin. You can find his Twitter handle on the right. And it basically describes the current and future. I'm going to focus a lot more on the future, and I'll leave this for the advanced reader, the left one. And I think the fastest way to read this is just look for this LLM symbol and see how many of these blocks have gone from some other color to one with a brain box, which means a LLM or a modern method is helpful. So document understanding is significantly better. This includes problems like parsing, structured information extraction. Instructor is a very popular library. I think they're close to 900,000 installs per month, and basically there are going to be a million installs per month within before Christmas this year, right? That's the trend line. So that means there's a lot more interest in structured document extraction than even memory. Just putting it in context, right? Uh, Query understanding, I think, is a very vaguely defined problem, and that makes it partially difficult to make progress on it. I think if query understanding, decomposition, augmentation, rewriting, including methods like hide, I think if there was a standardized data set like a BR 13 equivalent for this, I think this area would move significantly faster. Chat answer is basically what we are calling RAG today. The entire annotation pipeline, the data annotation, labeling for models, LLM as a judge has moved this cost of the process dramatically lower. And of course, all the signals for retrieval themselves, including VectorDB, are now significantly cheaper and faster both. So I think both latency, cost, throughput, all the performance characteristics which you had, all the performance challenges which you had, have now changed in meaningful ways in the last 2 to 4 years. And this is not like the most ending point which I made around vectors is it looks like it's only about vectors, but in practice, a lot of the hard negative sample mining which we're able to do for domain specific fine tuning of embedding models, actually that synthetic data also comes from LLMs. So there is a feedback loop of sorts playing here that folks use a lot of retrieval methods for deduplication to train LLMs. For instance, both Snowflake and Meta and Apple have described that kind of data cleaning pipelines. And then people use synthetic data generated from these OSS LLMs, which allow use of these LLMs for synthetic QA, like Mistral had some licenses like this, and so does Snowflake. Then they use that to make their own embeddings quite often. So there's a loop synergy which has kind of just started happening there. So search, in many ways, the non-infrastructure parts, the ones which focus on ranking as a problem and not just retrieval, which is the quality part, is this better, has changed dramatically.
Mm. And yeah, thanks for bringing up data annotation as well. We have seen like Scale AI completely without existing as now like the fundamental company for all these large language model builders. I mean, it's a separate discussion about how they are doing the annotation, but they are like at least you cannot discount them. And also, you brought in like a very nice the diagram also had this vector DB. So I want to know, how do you think vector DB is critical? Like, is age old SQL will do the job, the RDBMS systems, or you think like vector DB is critical for any modern let's say RAG or search system?
So I think there's two different problems, or let's three different problems in terms of how we do storage today, right? So storage has three different use cases. The one is storage for analytics, and we now increasingly call them OLAP or warehouses. We have transactional DBs like RDBMS, and I would argue even Mongo is loosely a transaction DB. Like, yeah, I mean, we use it that way for the most part. I know folks who use Kafka also as a transaction DB, but we'll not go there. That's a different mess. I think vector DBs are closer to a search use case, and that is how they should have been built or designed. That they're in the business of solving search. The market opportunity, so to say, was that all the classical search systems, including Elastic and Lucene and Solar, and let's say the companies built on this, including Elasticsearch, the commercial company built around it, and then let's say Algolias of the world. There's just few more. I think Types and Souls started out that way, which is an open source counterpart. MTV, which is a Rust implementation of BN25. I think all of these folks started in with the text and token first view of the world. So they all had BM25 as a first class citizen. They had different tokenizer and focus. a lot more boosting and those kind of focus. And it was basically built around the BM25 index, key design choice. And then all the vector DBs basically said the key design choice is we will build around the HNSW uh, graph, like the hierarchical navigable small worlds, if somebody wants to Google it. HNSW is a relatively well known idea going back to 2016. A lot of large enterprises have implemented that internally also. So, for instance, from what I vaguely hear, and I don't know if there's a blog on this, Pinterest used to have a HNSW implementation back in 2017 for their early stage, one of the pipeline in their recommendation system, because Pinterest has spent a lot of time in doing cold start solutions. So this was a signal into their cold start breaking. Ads used to have version of these, some image only ads. If they needed ranking information, they would use this when ResNet 34 was a thing. So the HNSW implementations are older than, like they're as old as the paper basically. Like the moment the paper came out, people did try out implementing that, including at Twitter from what I hear. So, so that's the product slash engineering difference that these people started as HNSW index is the main, and we build the rest of the ecosystem around it. So BV8 went ahead and added the next index, which was basically drive. Quadrant and went ahead and added a different index, which was sparse vectors, but built on the same vector as an idea. Like the underlying data structure is still a list, right? It's a list of floats or list of integers. So the underlying data structure is very different, which changes your latency, throughput, or your access times from the RAM and disk also. So that is what changes. Now, in this search systems like Elastic, which is probably the most used, understood, they have a little bit of a challenge. Their existing BM25 index does not, and the ecosystem around it of devs and add-ons and best practices around it, their ecosystem does not lend itself very well to the view that, okay, there are no knobs. Everything which has to be learned via these three or four components, which is the key, the text itself, that's the BM25 index or variant of that, or the vector itself, and re-ranker. These are the only three components which you basically play around with. But the ecosystem there encourages a bunch of more tinkering and playing around, which is like, please do boosting, do this facet search, do that. I'm not saying that those methods are wrong or incomplete. I'm saying that they do not put enough elbow grease into making these three components, which will probably have more alpha today than their other existing methods. Their other existing methods are also useful, but this will probably now do the heavy lifting, which means that for a newer player coming into search, now be it on the infra level like Pinecone or Quadrant or VBA, or a user, it's easier to put more effort into making a great embedding model and covering your edge cases and profiling your queries to keep improving the embedding model and re-ranker. Then it is for them to figure out, oh, for this keyword, I need to do this boosting.
Okay, that brings us to an interesting point where I feel like, people like me or generally like YouTubers, what we do something bad is that we oversimplify everything. We create like an abstraction and we make it so easy that people start believing that that is everything. Like for example, if you go to RAG and see a typical tutorial on YouTube, there'll be like an ingestion and you use Llama Index or LangChain and you ask question and answer. And everybody is happy that now I know how to do RAG, and the people go to their companies and they start doing this. And what do you think is like the biggest difference, or like the delta between what you typically see as typical RAG solutions online, but when you have to do it production ready, how is it different?
Okay. So this, I think we can give two very public examples, right? So one is, I think the search generative experience or something from Google was one of the largest RAG deployments, followed by Perplexity. And I can show top five cities, right? So I'll show you something fun. So there are different types of queries and intents, right? Of course, and Google has done that, solved that for a very long while, right? Uh, so let's say this is my query, right? Top five cities in India for vegetarian foods in 2010, and this is basically a food history question, right? And what these guys are trying to do is they're trying to pull out Drink and Explorer Guide, Vegetarianism by the country. The entire first half is basically just Wikipedia, right? Then there is India's meat map and things like that. So this is press coverage, and the rest of it has no time filter. It has no, the India filter is also kind of weak. These are just the cities which are overrepresented on the internet as vegetarian. Uh, and there's just so much incompleteness in this answer that you cannot trust it. So, for instance, you don't know if these are the top five cities. You know that, okay, these are some five cities. You don't know what it is top five by. Ideally, the system should have asked you, okay, what do you mean by top five? By volume, variety, quality, popularity? What does the top five mean? Right? This is a very common failure mode of search in general, that you're ignoring a part of search query itself. And this is, in this particular case, Perplexity does a good job of doing some sort of query decomposition where it is able to go and say, this part is about vegetarianism and this part is about India and this part is about cities, right? But not this is not always the case. If you do a comparative query, for instance, this may not always work. So if you did, let's say, sparse versus dense vectors a few weeks ago on Perplexity, it was a much worse answer than today. Right? Today the answer is much better because I think the query understanding is improved. So I think that is like a usual failure mode that people do not map the query well to what their actual user search pattern might be. If somebody is searching for kadai paneer on Google search, you have three options. You can show kadai paneer recipe, you can show text recipe, you can show a video of kadai paneer recipe. You can explain what kadai paneer is, by the way. Right? Kadai paneer in Germany means something else than it does in India. And you can show restaurants nearby which have kadai paneer. And then they're all very different intents and you have no idea which is which. And I think everybody who designs search or RAG systems does not factor that in. A lot of these RAG systems basically have the same search experience for the CEO and the intern, which makes absolutely no sense. Right? You're making something which is supposed to be bespoke and personalized and expert user. That is why you are going from public search like Google to an internal search, right? And the fact that it tries to give the same answer to the intern and the CEO is just either wasteful or lazy.
Yeah. And because you spoke about also, the improvements happening in Perplexity, one of the things that I've always heard about is that when people implement these solutions as part of their enterprise problems, not necessarily they have like an internal metric or let's say validation or eval for them to monitor whether it is something is improving. I mean, that practice does not exist very well in LLM as much as it used to exist in the ML space. What do you think about it?
I think search evaluation or RAG evaluation in general is, I think, a harder problem, partially because the systems are newer. When I say harder, I don't mean that the underlying engineering is hard. I think it's harder because there is no consensus. So it's a human understanding problem showing up as a evals problem. So let's say if I were to design evals, let's take the same example, right? I'm building enterprise search like Glean, for example. Should I weigh the queries which a CEO makes as 10 times more than the intern? 300 times more than interns? Should I, like, how do I weigh it? Like, how much more important should I give it? Sure, it is more important, but how much more important? Now, within that, are all queries from the CEO equally important? Maybe sometimes the CEO is just checking for how many employees do I have in so and so function, like customer support. Is it the same importance as what was my revenue from Montreal last quarter? I would say that one of them, although both are numerical answers, one of them is way more urgent, and one of them is like, yeah, you can take 3 seconds or 20 seconds. It doesn't matter, right? Like if you're looking revenue numbers from the last quarter, the latency is not your primary challenge, right? So that kind of trade-offs can be made. So that is one part. I think it's non-trivial to make a good eval set, but I would say the hygiene for evals is largely missing, and a huge reason for that is that the equivalent of the scikit-learn train test split method does not exist. And I think the moment we have the equivalent of that as a ecosystem, we will see a lot of folks adopt that. So
Mhm.
now whether that ecosystem method, that I think there was a huge, not a huge, but I think there was a meaningful amount of time. The entire machine learning work was happening in PyTorch, including reading of file types, like which would happen in OpenCV or a text-specific loader. The only use of the scikit-learn import was train test split, that one function, right? That was the only function used from the entire scikit-learn library. I remember seeing a lot of code bases like that, especially those POC collab notebooks, right? I think we don't have an equivalent of that for search. We have a bunch of these metrics, which is like NDCG and all of these. And I think they're all, but we don't have a good way to do this. So that is one reason. And I think that is a huge reason in adoption. More Second is that for more mature folks also, I think all of these metrics are quite, I would say it's quite easy to overfit to them. I'll give you an example. There's a very interesting paper from Microsoft Bing, I think, which came out last year or this year, where they describe that all through late 2000s and early 2010s, Bing was optimizing for this metric called NDCG, normalized discounted cumulative gain. It's basically a way of saying that the best result should be first. If it comes on first, great. If it comes on second, less great. And a exponential decay, like 1 by k decay as it gets uh, best result. And then and so on. The second result, which should have been second, should have been on second. If it is first, bad. If it is on third, less bad, and so on. The exponential decay again. So that kind of thing. And fun questions on metrics like that, right? Quite often it did not agree with what user preferences were. But the company, all the way up to the board level, optimized for NDCG. So NDCG was expensive because you needed a full judgment list of at least top K results that, okay, we are getting the full ordering, exact ordering. So it's expensive to evaluate. Second, because the company was evaluating completely on that, they ignored user preferences quite often. So if you search for a restaurant name and it was something like Thai food or something common, you would get results about Thai food and not the restaurant near you, right? That is quite annoying if you're building a general purpose search. Just giving an example. On the other extreme, companies like Facebook, when they were launching out video in their feed, they optimized completely for user interaction, right? Like user preferences, like clicks and views and view rate and things like that, which led other kind of problem in their feeds, which were all videos. Because if you even if you watch a 10-second video, that's more time spent on that post than let's say a 3-second funny Facebook post. So you would end up over optimizing and committing to video, right? So every platform today have devolved into basically Instagram Reels, partially because that you optimize on or TikTok actually, and then this devolution of internet spaces to these short form video, at least in part, is because everybody's trying to optimize for one function or one variety of user behavior, which is time engaged. That's so it's easier to over optimize in either direction. So maybe the users will, the highest quality users at some point will churn out, right? So very famously, for instance, Peter Thiel himself never uses TikTok. His children don't have access to internet, right? Are you saying that there is somebody on the internet who is like, I assume Peter Thiel is definitely in top 5% of humans who use internet, right? So you don't want to lose. There has to be some platform which he is using, but it's not yours because you have optimized for somebody else completely, right? So there's also a trade-off: what kind of folks you want, what behaviors you expect from that. This problem of user behavior and consensus within the company shows up as an evals design problem. So if the company is engineering, first we will say, oh, the evals are missing or incomplete or inaccurate or any of these three. Like, so for instance, smart being engineer would say, oh, NDCG is not complete because you're not taking the user A/B test into like click-through ratio into consideration, while somebody at Facebook would say the content should matter and they would get shouted down by products, then it shows up as a product metric. But it's actually a consensus of what does the company want or the product want, showing up in different parts of the ecosystem. And metrics design itself, like I just took NDCG as an example, but each metric which you pick, NDCG versus precision versus recall versus, let's say, mean reciprocal rank, they all have their slight trade-offs, which reminds me, I think the example of 1 by k which I gave maps more closer to like the mean reciprocal rank than to discounted cumulative gain, because the gain math is different. So yeah, and also like what do you discount by and what do you normalize by? There's folks who have gone to debate on this also, quite obviously, because should you, as a very bad example, should you normalize by how many searches is the user doing on your platform? Let's say I'm somebody who is a power user. So is that a good thing or a bad thing? Am I forced to do more queries because was not satisfied or because I know I will eventually get it right? Right? So your normalization and discounting has to factor that in, so to say, in the metric design itself, eval design, when you're doing click through like NDC or something like that. Now, this problem in RAT is compounded even further because you do not get direct feedback of whether somebody is happy with the retrieval or unhappy. All that you get is a thumbs up, thumbs down on the entire answer and not on each link or something like that. So the granularity is actually gone away from you. So you lose even more. And if somebody, let's say, if you go to Perplexity and you open a link and Perplexity knows that you opened the link, is that a good thing or a bad thing? Right? Like, how do you make an opinion on that? Right? That's it's non-trivial for a company to make that trade-off. Yeah, I think I spoke at length on this, but yeah, I'll pause here.
I think everybody after hearing this, they will understand evils are hard. So I think that is going to be a key takeaway after this.
Yeah, and I did not say that it depends. I said that okay, these are the specific areas which you have to pay attention to.
Yeah, I think a very important takeaway for me from this answer is that it is not just a computer science problem or an engineering problem. It's just like you have to understand what your business wants, and then you have to design the evil framework or whatever it is internally based on that. Not necessarily like something is like working for, let's say, somebody, and then you just literally copy and paste it here for your company.
Oh yeah, and when I say copy paste, right, I mean maybe the metric design can be copied. So for instance, you could use ragas, but then the examples which you use for evaluation, those have to be tied to your user behavior, right? Or you could use ragas, TrueLens, Galileo, whatever you like, right? You could use LLM as a judge for all I care, right? Just use GPT-4 over 4 Mini or Sonnet 3.5. A point is that it has to map to your end user preferences and what part of that preference you want to capture as a business or product.
Yeah. So another thing that I observed, like in the conversation, is that it's my perception that your focus more looks like on the ranking side. Finally showing. But do you also think like the retrieval part is like very critical for RAG, or you think that is like almost like a solved problem, and we should focus on ranking and finally showing the results?
It's a so I think we have very fuzzily defined retrieval and ranking as a community, but largely I think of these problems as very hand wavy definition is this. If you're starting with 1 billion records, till the point you are working with 1,000 records is retrieval. So basically 3 orders of magnitude, and sorry, 4 or 5 orders of magnitude, and then anything beyond that is ranking. This is how a lot of recommendation systems, for instance, operate, right? Like you start with all the entire feed of, so to say, and then you narrow it down to get the final ordered list of 20 items which you see in your Twitter or Instagram or any of these feeds, right? I wouldn't say that retrieval is solved. I think we have a local maxima where we do not have an incentive to do better on retrieval. So as a historical analogy, right, a lot of retrieval methods before the hyperlink became common on the internet were based on the content of the text, like we do today, right? Embedding is a text, the keyword BM25 is a text, and so on. It's a content based signal, basically. And one of the key insights which Google was that a random walk over a graph captures a very different but useful signal on this hyperlink graph. And it might be a cyclic graph, and that's fine. We'll just treat it as a DAG and to treat it as a DAG, we want to do a random walk. And then we'll just do that as many times as we can, and we'll eventually have enough coverage to do approximations. And that's amazing, right? And that gave us a whole new way of thinking about retrieval itself, but not ranking, right? It reduced the amount of information which they had to consume itself also, right? That changed retrieval. The second retrieval change happened when we designed feeds around your follow graph. The follow graph or friend graph in Facebook really changed how your retrieval really worked. The candidate pool shrank dramatically in volume, but the latency requirements were dramatically better, right? So if you clicked like, it had to be factored into the ranking algorithm with a very fast, like the lag was not, you could not like have a 30-minute lag when Donald Trump tweets, basically, right? So that kind of thing. I think the third iteration of this quasi happened in parallel when e-commerce search was getting better and their recognition systems got better. And then the third happened when we moved away from the friend graph and follow graph back into the wider internet, which is basically what TikTok did. And today Twitter feed tries to do, right? The For You page is basically like the entire internet with a slightly more preference to your follow or friend graph. And this has its own different set of challenges. Like, okay, how do you do that candidate selection for even ranking, where you can spend more compute? And a lot of these approaches are based in some form of multi-armed bandit. So that is why in your feed you will often see the same accounts very often if you have seen their content but not followed them, to the point where you forget that I actually don't follow them, right? That this happens quite often on Twitter and TikTok and to some degree on Instagram also. So that's a third internet scale retrieval iteration in many ways. And each of these retrieval pressures, like the first one came from basically internet search as a problem. This last two came from recommendation systems and feeds as a problem. They're very different motivations. And then there's a whole parallel history of this happening in low latency context for trading firms and ads and bidding for ads systems, which is a whole different conversation. So yeah. So I'm saying this is a local maxima, I think, but as the requirements evolve, let's say TikTok really forced everybody to rethink their feed design because of their multi-armed bandit approach, where they were gradually exposed to more people and so on. So yeah, I think this will happen. I think this is a local maxima, and we'll find something better.
So if we leave out scale for a minute, let's say TikTok, Twitter, YouTube, if we leave out that scale, let's say an average company that is not, let's say, consumer facing, not a B2C, B2B, internally they want to build a RAG. What would be your a suggested tech stack? What would you suggest them? Like start this, do this, do this. Like you mentioned Ragas, like on the way you have mentioned Quadrant a couple of times. You mentioned Fast Embed before because you know that is one of the easiest ways to embed. So what would you suggest as a tech stack, like a basic boilerplate?
So there's two different parts, right? One is how do you do a fast POC where you're optimizing for I want to do something over a 2, 3, 5 day window and take it to my manager and then get next 2 months allocated to this project. So let's answer that 2, 3, 5 day POC first. I think you should start with something like Llama Index or LangChain. Take any of their better RAG implementations with a lot of abstractions. When I say a lot of abstractions, I do not mean chain as an abstraction, but like an implementation which ties to what you think your manager will like. So as an example, let's say your manager wants to be able to query spreadsheets. So make sure that edge case is well covered, right? Like then you will want to have a tabular search from Llama Index, for example, as an example. Let's say your manager is somebody who reads a lot of papers because you're in a machine learning organization. So then optimize for, okay, I should be able to parse LaTeX or PDF or HTML. I should be able to segment those, chunk those properly. And either are corresponding demos, tutorials, implementations of that in LangChain, Llama Index, Haystack, whatever that is. Use that, do a POC, get those 2 months. Once you have those 2 months, you flip and say, okay, I'm going to spend 1 or 2 weeks building for the users, like whatever is my end user, and I need to start with that stack. If you need something which is very low latency, high throughput, or updating very fast, let's say like emails, where there's a lot of inserts happening in the working hours, then you might want a vector DB like Quadrant. And fast embed so that you can do it at a high throughput, extremely data parallel fashion. Or you might say, oh, I don't need any of this. All that I care about is exceptionally good retrieval. So you say, oh, you know what? I will just use LLM as a re-ranker. I have so much time, and my LLM, I can use GPT-4 as a re-ranker. I just have to optimize it prompt. That's also fair game. There's nothing wrong with that actually. So I would say like build to specification which you have. The RAG system basically has only three constraints, three axes to think about. How fast, how good, how cheap. These are the only three axes. And if you can answer in all these three questions, how fast you wanted, how good you wanted, and how cheap you wanted, you will have 90-95% of the specification to build for the first 2 to 6 months.
You do a lot of consulting. Let's say there is a company that comes to you and then says that we have got the traditional, let's say, search system, and we want to move to whatever it is cutting edge, and they have to pay you something. But how do you make them believe that this is what they should do? Like, what is the value that you would show them, or you would say that okay, this is the value that you would get if you move beyond all the technical reasons? Like, how can somebody show that value to move into the cutting edge systems?
This is actually a human problem which we're trying to answer with an engineering question. It's a human question hiding in an engineering question. The first question to ask is, why are they looking for somebody outside? What
Hmm?
part of their queries are they unhappy with? And there have been situations where I said, okay, I understand why you are unhappy with this, but I'm not the right person to fix it, right? So as an example, e-commerce search, right? The e-commerce search latency and cost pressures and design is so specialized, and we have so many people who can do it better than me, right? So for instance, if you're looking for a consultant, we should probably go to Open Source Connections, which is a consulting services team which specializes in that kind of challenges, right? So if you're building, let's say, search for Swiggy Instamart, you should probably talk to Open Source Connections and not me, right? As an example, if you're building a recommendation system where somebody is chatting to and saying, oh, you know, I want to eat something spicy, but because but with the awareness that it's raining and this person has ordered something else, basically closer to a recommendation system, then you should probably talk to me, right? But then the constraints are not latency or cost. The constraints are quality and cost, right? It's very different. So that is part one to your answer, which is like how do you convince somebody or demonstrate something. Now the engineering part of this is quite often the engineer within the organization will know that this is my rate limiting step. When I say rate limiting, for instance, they might say, oh, I am spending so much time on indexing that the approximation from HNSW is not ready and I have to use exact search and hence it's slow. So how do I make faster writes? So now this person has a very clear infrastructure problem which you can solve by simply tweaking whatever vector DB they're using to do in memory writes or something like that. They might say, oh, everything is working, but when I do get the correct results and everything in retrieval, the LLM ignores it sometimes or hallucinates even if the retrieval is perfect. So you can then look at the prompt and look at DSPY and say, okay, this is how I select the correct few short examples. This is how I teach the LLM to, and sometimes, especially for OpenAI family of models, I've noticed, and to some extent even Mistral, that I've noticed that reordering the results to have the best results at the start and the end helps. And not in, you don't want a third result to be at third in the order. Sometimes you want it to be the end. And so you basically have first, second, fifth, fourth, third, basically, if you're sending 5 examples, for instance. And then that seems to work better. So you can run a battery of these quick experiments if they've given you data access. If you have not given this data access, you basically take whatever external benchmarks or data access which you have, write down the set of experiments you would want to run, and share that with them. I have clients who are more than happy to run with those, and that's great. Those are advisory. They have enough engineering competence to run that. And then otherwise, you can come in and say, please give me data access and I will run this experiment, build an eval with you, which is probably more valuable than actually this experiment in isolation, and we work accordingly.
And do you also have to show like what is the dollar value impact that will be impacted if you do it, or you just talk in terms of engineering or human metrics?
I like to talk in terms of dollars. So quite often, when I say dollar, that usually maps 1:1 in some sort of time or effort saved. Sometimes it is cognitive friction saved. So we had a search experience which was built almost exclusively for CXOs, but within CXOs, it was the main buyer was basically the marketing counterpart. And somewhere during the discovery conversations, I realized that this requires enough marketing expertise that I should just not pick it up, because it was not marketing in general or like ads marketing, but it was very hyper specialized relationship sales, which they interpreted as marketing because of the business they were in. So I'm not great at building, let's like a sales CRM masquerading as a marketing and then building a RAG over it. But I would have to build a lot of company specific process understanding to iterate on it. So I walked away because I would not be able to convert it into a dollar value. So I like thinking in terms of dollars. In fact, one of the mental goals which I have is that I should be able to help companies either make or save $1 million, give or take, within the next 12 months, which I think is doable. But yeah, that's the personal, one of those nice to have things.
That, that that's nice. This is probably like the longest episode that I've recorded. So I want to know, you have been in this you have been in this space for I think last time we met like 4 or 5 years before. That time everybody was talking about named entity recognition. Like Fast API was starting up, people were trying to wrap it up,
Yeah.
and now everything has changed. And throughout the space, you have maintained your alpha there. You are a figure there. How do you keep up with the pace? Like any tips for people to like learn continuously, keep updated?
You can either have a social life, sleep, or stay updated. Pick two.
That's nice. Yeah, as somebody who sleeps at 2 a.m., I can relate to it.
Yeah, I mean that's the honest answer, but I think a more tactically useful answer is this. I look for ideas which are going from this transition of being stable in research and moving towards engineering. So as an example, New Big Lab at CMU, I think they've done a lot of work in low resource language, but a lot of their methods are still kind of bespoke in the sense that they do not transfer from, let's say, one ecosystem or family of languages to the next. And a bunch of these research design problems exist. So that means a lot of their work is not ready for the transition. On the other extreme, you will see, let's say, the Mipro 1 implementation in DSPY was basically a for loop on steroids, right? That was more engineering ready. The research was half baked. I don't think it was as mature as it was advertised, right? You can also look at ideas, let's say, like Colbert, again from the same team, that I think the late interaction idea is extremely powerful, and they made a lot of progress with the played index as well. But I think if they had spent a lot more time on the indexing of Colbert vectors, making it ready for late interaction and then Maxent scoring, that idea would see a lot more adoption. Because and I think they also reposition. I think the positioning was also a little off. If they had positioned Colbert as an interpretable learned model instead of, let's say, re-ranker, which is basically how people use it today, they would have gone way further. This is how I look at it, like because they can show keyword highlighting and things like that. In fact, one of the things which Vespa did right is this exactly this in their call their demo. They show the highlights. Okay, these are tokens where we paid attention. Actually, not attention. Basically, where we had maximum. This was the score, maximum similarity score. Uh, then obviously there are ideas which I think that's a good taste which you can develop, that ideas which are maturing from research to engineering or the other way around, and you get a sense of it over time. I think because, and I think it's easier for folks like us who have seen these transitions a few times. Like we have seen this transition with PyTorch in particular. We have seen this transition and decline with Keras. We've seen the peak of Gensim and then the extremely rapid decline of Gensim, especially after Elmo and sentence transforms. They basically got butchered. They could have kept up for what it's worth, right? Because Hugging Face was quite not there for a very long while. Especially before the hub. So if Gensim really pushed for it, they could have caught up to sentence transformers. We have seen spacey defaults being exceptionally good, right? And basically running on the power of very, very, very out there exceptional API design, right? Even the NLTK had the Stanford brand and everything, and a lot of folks went out of their way to discover and use spacey, especially within the field, right? People who build NLP pipes often like that over NLTK for a bunch of different reasons, but API design had a huge role to play in that, more than performance, I would say, in some cases. So yes, I think that's the more, I think, longer term answer for somebody who's trying to think about, let's say, building a career or spending next 2 3 years in this space. That look for ideas which are ready to go from research to engineering. I think one of these ideas today is function calling. I think function calling is very in that transition right now, where there are a lot of people using tool usage of function calling for structured information extraction or some version of agentic behavior. But right now, the underlying LLMs are not quite there. But I think within the next 2 years, it will get there.
And where can people follow you? Where can people learn?
Learn from me. I'm going to have a course on search for RAG very soon. We are planning to launch on 1st of September. I also should post a lot on Twitter. Not always about search. Sometimes it's just about Korean K-dramas. And Hometown Cha-Cha-Cha is amazing. And what else? And I've started to post some of my Twitter things on LinkedIn. So that's probably another place to look at. Yeah, so if you're the person who prefers long form, LinkedIn is better for you perhaps.
Any advice for fresh graduates, like let's say who want to get into the space?
If you're watching this from India, which I think a lot of your followers might be, uh, go apply for a master's or a PhD program, preferably in a top 20 school from csrankings.org, and work for a company which has more GPUs than God thought was possible. That's probably the two criteria which you should optimize for. For everybody who cannot go to US in particular for any other reason, look at Europe and Singapore. If you cannot do that, also try to build a way in which good opportunities come find you instead of the other way around. Now, whatever that mechanism is for you is something going to be specific to you. For me, that has been doing a lot of open source work, being generally accessible online, be it through WhatsApp, Twitter, whatever that channel. That will keep changing over my entire lifetime. But I go out of my way to make sure folks can casually ping me anytime.
Thank you so much, Nirant. It was very insightful. I think a lot of people have to start taking notes, maybe start using LLMs to take notes from the discussion, but it was very insightful. And thank you so much for your time.
Thank you. Thanks for having me, Abdul. Have a
Thank you.